Good morning, this is Mrs. Webb. We're going to go into Module 4 with the Eureka material, and it's on probability and statistics. This first lesson, it's lesson 3 in Module 4, and it's on calculating conditional probability and evaluating independence using two-way tables. But basically, you're going to do basic probability, and then I'm going to show you conditional probability. As usual, Eureka makes it really big and long, and it's not that big of a deal. But I wanted to let you walk through your notes, and the best thing to do is to get your notes out, and I'm going to go through all the examples and the exercises with you, and that way you can also write down if you have any questions. So I'm going to start with example 1. Students at Rufus High School. Let me get my pen working. There we go. So I'm up here. Students at Rufus High School were discussing some of the challenges of finding space for the athletic teams to practice after school. Part of the problem, according to Kristen, is that female students are more likely to be involved in after-school athletics programs than male students. However, the athletic director assigns the available facilities as if the male students are more likely to be involved. Before suggesting changes to the assignments, the students decided to investigate. Okay. Then it says, you go to the next paragraph, it says, suppose the following information is known about the high school. You have 40% of the students are involved or participate in one or more after-school athletic programs offered at the school. It's also known that you have 58% of the school's students are female. So, what they decided to do was do a hypothetical 1,000 two-way table. And you're going to find out why they decided to do 1,000. It makes calculating and the probability very easy. Let me show you what this looks like. So when you do a two-way table, there are two different things you have. You have how many of the students are female, how many are male, and then up here you have how many of those participate in after school, how many of them do not. Okay, and we're going to make it 1,000 students. Okay, now a two-way table, you can read across the rows and get a total, and across the rows and get a total. You can also go down and get a total, and I'm going to show you how that works. So what cell in table 1 represents a hypothetical group of 1,000 students? So I'm going to say it would be cell 9. That's where we're going to put the 1,000 in, because we picked it. We're the one that decided to use 1,000 because I know it's going to make it easier. And I'm going to say if I have 1,000 students, so total students, if I add it this way or this way, it's going to have to equal up to 1,000 students. Okay, now what cells in the table can be filled based on the information given about the student's population? Place these values in the appropriate cells of the table based on this information. So they did tell us that they have a total of 58% of females, and they could tell us how many total students participate. So you're going to find out that cell 3 and cell 7, and look, they filled it in for you. 580 females, and then 400 of all the students, whether they're male or female, participate in the athletic program. Okay, so can you see now why it was very convenient to use 1,000, and then if you do 58%, you know it's 580, 40% is 400. Now we're going to go through and we're going to say based only on the cells you completed, so only on the 3 cells I completed, which of the following probabilities can be calculated and which cannot be calculated? Calculate the probability if it can be. And in case you don't remember probability, it is, when you think of probability, it's how likely is it to occur. Okay, so the probability that a randomly selected student is female. Okay, your probability is, okay, if it's going to be female, there's 580. But I am selecting from what? All the students. and there's 1,000 students. So the probability that it's female, there's 580 out of 1,000. Okay. The next one is the probability that a randomly selected student, and this is the important part, they're looking at students as a whole. So I know underneath I'm going to have 1,000, because you can think of it, that's what's in my bag. And it says participates in after-school athletics program. Well, this is the total that participate, so it would be 400 over 1,000. The probability that a randomly selected student who does not participate in after-school athletics programs is male. Well, that would be, let's see, they'd have to be male, and they randomly selected out of all the males. I could probably figure out the males though, but I don't have that filled in right now, but it would be right here. And I can't do that because I don't have that part of the table filled in. It says, no, it can't be calculated. We need to know what the value of cell 5 is. And that was the one that we circled up here. Okay, the probability that a randomly selected male student participates in after-school athletics. So of all the male students, okay, and I need to know what's the probability from all the male students that they participate. I would have to know from cell C4, and I don't know that one either. Okay. Let's keep going. Okay, the athletic director is going to have to give us some additional information. So he's going to give us some information. It says 23.2% of the students at Rufus King are female and participate in after-school athletic programs. So he says the students are female and participate. Notice that word and. That's kind of important. So when it says and, both things must be true. And if it's 23%, 23.2%, I'd put 232 in right there, because they're female and they participate. Both of these things have to be true. Okay, so now they want to know, can we complete the table? And I think you can complete the table. If you know this is 580, you know 232 plus something has to equal 580, so you would say 580 minus 232 to get that number. If you know there's 1,000 students and 580 are female, I bet you can figure out how many male. You'd say 1,000 minus 580 would give you that one. So I'm going to end this video now and have you go and fill out that table for me. And I will go to video 2. Thanks.